I'm going to start off with a short introductory presentation on quantitative and qualitative data, followed by a quantitative data workshop. After that, we're going to have a break, and then Chiara is going to take over for the qualitative part. The guidelines for the presentation, and it's the same as other workshops being hosted. So mute your mic if you're not talking. You can just use the Teams chat to communicate, and all materials will also be recorded. So let's get onto the qualitative and quantitative data aspect. So you all are most likely to be quite familiar with qualitative data. It's very much used by designers, and we often see it in the forms of focus groups, interviews, using probes. And it's very often an inductive approach to research. And an inductive approach means that you try to distill a theory or find patterns from observations that you see in the field. And what's also a characteristic of this type of research is that these sample sizes are relatively small. Very often there's less than 50 people involved. And for student projects, it's very often around 10. But you also need less data when you're doing qualitative research because it's more easily saturated. When we look at quantitative data, it's very often large sample sizes because here you also want to find a saturation, like a point at which new data doesn't really affect the existing data you have. But it's much more sensitive for quantitative data. And for here, we often use a deductive approach. So you start with a theory, and you want to see if you can also see that in your observations. An example could be to confirm a hypothesis, for example. But these things like the inductive and deductive approach are very much generalizations. They're all exceptions to the approaches. So it's not really set in stone. You can still use quantitative data to explore a data set, for example, finding new market segments upon which you can target your design. And qualitative data can also entail very large groups of participants. Think of national surveys, for example. When you want to conduct a quantitative data analysis, it's very important to know what kind of approach you're taking. So we have, in general, the data-driven approach, which is inductive, like I just mentioned. So you start with looking at a group of people and try to distill what you see. Can you find patterns in it? Can you make a theory of that? Example of that could be, do all the users in your group experience the same problems? That would be a data-driven approach. A theory-driven approach comes from the opposite side, a deductive approach. Do you see what you expect to see? So there's a theory, perhaps there's a framework, and you want to apply that to your data and see if what is theorized on the topic is also the same as what you observe on it. Now, when you want to make use of your data, you have to realize what kind of data you are dealing with. So there's 4 categories of data. I'm not sure if you all have already seen this this distinction, these categories. The curriculum changed a lot over the past couple of years, so I'm not sure if everyone got it. But just to go over it real quick, the nominal data means there's no meaningful differences between values of that data. So you can often use it as dummy categories. In terms of design, it could mean that you have data collected from your participants who either not used your design or have used your design, so you can use that to categorize and make a distinction between the groups. Other example of that would be demographics, like in gender, the country someone is from. There is still a different meaning to the data, but there is no meaningful difference between the two. Next to that, we have ordinal data. So that means there are differences which you don't know how big the differences are. An example of that would be educational levels. You know that university is considered higher than vocational education, the MBO. but you don't know how big this difference is. You just know the order between the two. Then we have interval data. These have meaningful differences, such as temperatures. You know that 50 degrees Celsius is quite a much hotter temperature than minus 10 degrees Celsius. But you cannot you cannot say that it's twice as hot, because when you use a different scale, for example, when you go to from Celsius to Kelvin, it doesn't hold up. So you cannot make those transformations to it. And then there's ratio data. That's the most detailed, so to say. You know, when you know someone's height, you know how long he is, how much taller he is than someone else, and also the ratio between those two data points. So you can make a distinction from it. When you perform a statistical test, you often assume that there is a normal distribution, and it means that the likelihood of a point getting a certain score is at the center of the curve, and the probability decreases as you go outwards. And this is often a requirement for statistical tests, only for parametric statistical tests. And the data that you are allowed to use from this are only ratio and interval data. So if your data is normally distributed, you know what newly obtained data will likely look like. So it's much more effective in drawing conclusions from it. Now, when you want to see if your data is actually normally distributed, you can use a QQ plot. It's frequently used, and here you set up the quantiles of your data set as opposed to the normal distribution itself, and it forms a diagonal line. And if the dots of your data are plotted in a diagonal line, that you know the data is normally distributed. Now, there's not really a harsh limit on when it's not or when it is actually normally distributed. So it's all very much done on feeling. So if we look at this plot, for example, you can really tell that on the bottom, it doesn't match up with the line anymore. This means that the data is skewed to the left side of the spectrum, like you can see on the left graph here. So there's a much higher probability of something happening on the lower incomes in this case, as opposed to higher incomes. And when you're dealing with monetary data, this is very often the case. There's a very large group making a very similar amount of income, for example, and there's very few exceptions at the top who are really billionaires. So if your data is not normally distributed, you can do transformations to try and see if you can make it normally distributed. One example of that would be a logarithmic transformation, which you can see here, and that's also very often used when you're dealing with monetary values. And then you can use the logarithmic transformation as an input for your statistical test. A different example of that would be a square root transformation, and that yields very similar results. So very often when your data is not normally distributed, you just try and see if you can find methods to make it normally distributed. And if it's not, you could try in figuring out if you can increase the sample size. Maybe it's not normally distributed because you haven't asked enough people, so your data isn't saturated. Or you would have to find a test that is able to work with not normally distributed data. But that's outside of the scope for this session. What you also often hear at the faculty, at least, is what statistical test should I use? And there's also not really a definitive answer to that. Some asked what you accomplish when you can get it normally distributed. So when your data is normally distributed, it's much more easier to make calculations because you know what's going to happen or when the likelihood of a newly acquired data point, where it's going to be. So if you have data looking on the left, it's very likely for it to be on a lower income. But these statistical tests, they rely on a normal distribution to actually perform like you expect them to do. So you usually transform it to a normal distribution, and then you can actually use the test the way it's intended to be used. Yes, and it also makes it more predictable, your results, because you know where new points will be, or what's the likelihood of new points being within a certain range. So looking at the tests, there's not really a definitive answer on figuring out what kind of test you use. It's very also much dependent on the type of data that you have, what's the goal of your research. But just to go over some commonly used statistical tests, and then you can decide if it's usable for your project or not. One of the most commonly used tests would be a t-test. This checks for correlation. You must take into account here that correlation is not the same as causation. So a renowned example of that would be that serial killers are more likely to strike when the ice cream sales are also high, but that doesn't mean that ice cream sales cause serial killers to get another victim. But there is a correlation. Now, you often use theory to detect if you are finding what the cause of the correlation is. And in this example, it would be that when the weather is high outside, when it's a nice temperature, it's a nice sunny day, ice cream sales go up because people go out more. But when people go out more, there's also a bigger probability of a serial killer going out as well and striking for a victim. For design, you can use a t-test if you have deployed your prototype and you want to see what effect it will have. So when you're looking at sleep studies, you could see if there is a significant correlation between the usage of your prototype on the sleep of your participant, for example. Next, we have Chromeback's Alpha. This detects the relationship between questions from a survey. You often see it when you're looking at validated questionnaires, that they have very similarly asked questions, but not really the same. So they're often reversed in meaning. So one question could be if you liked a certain thing, and the other question would be if you disliked it. But that's just used to get a bigger certainty on both your perception of what the question means, but also it can help in merging the questions together because they have more, as a researcher, if you deploy such a questionnaire, you have more data to go from. So Chromeback's Alpha detects if the questions are actually measuring the same construct that you want to measure. And if they are very similarly scored, so the Chromeback's Alpha is high, you could merge the data by, you could merge the data and then you could treat that as more responses. So you will need less participants to your research. And finally, we have regression. So regression dictates the relationship between variables. So you often, and it's what it's called a multivariate statistic. So you use multiple variables. In regression, you have one dependent variable. So it's called in order to, what you consider what you want to measure. So in terms of sleep, the hours of sleep could be a dependent variable. And then you want to see what is the relationship between the hours that you sleep at night, the hours you have exercised that day, and how many hours you have used, your participant has used your prototype, for example. Then a regression analysis will dictate what the most important criteria would be for the sleep. But it doesn't dictate the value something should be. So an example of that could be the adoption of a product. So when a new phone comes out, you could do a regression analysis on how much customers value the screen size, the battery hours, and the size of the phone itself. A regression analysis could show that the screen size is very important for customers when they choose a new phone, but a regression analysis doesn't show you what the optimal screen size would be, only that it's very important. And for that, there are other ways in figuring out what is the size of the phone should be. Let's go on to the workshop aspect of this session. Are there any questions on the previous part? All right. So we are going to use a data set called the Killer App Data. It's a very renowned data set, and it entails apps being published in the let's see, the App Store from Apple. And the Killer App Data shows which app can be considered a killer app. So that means that it's been ranking in the top 300. So if it's a very popular app. And they also show from these apps what the category is in which they are downloaded, how many number of comments they have from people in the App Store, what the score is, like the rating on the app, the price, the size in megabytes, the number of updates that they often have, the time between the updates, how much experience a developer has in developing an app, and when the app was released. And what we are going to do in this workshop now is try to actually explore the data. Think of, can you tell what type of data is in every column? What we just discussed on the nominal, ordinal, interval, and ratio data. Try and see if you can recognize for every column what kind of values you're dealing with. And I would like to ask you to perform some normality tests, so see if there is a normal distribution. And if the data is not normally distributed, see if a data transformation can make it normally distributed. I've also written down, see if there are other appropriate tests, but considering the time, I don't think that would be suitable for now. You can download the necessary materials, so the data set, PDF explaining the data, and also a sample document for our studio that I've created for you on this link. And I would read, yes, I'll paste a link in the chat. Go. So let's see. I'll also go really quickly on how to start our studio. RStudio is a different program than what you might have experience with. I don't know if you have any experience with statistics or if similar types of programs, but it's quite contrary to SPSS, for example. So this is all code-based, but the syntaxes are really easy to get a hang of. So this is the program when you open it up. You can just go to File, open a file, and then select a product that you've just downloaded. And here on the top left of the 4 screens, you can see the code that you're currently working on. So the first step, and that would be to open up the data set. I've already put in some sample code. So if you want to run a line of code, you have to hold control and click enter, and then it will run that code. For the first step, it's important to also install that library readxl. If it doesn't automatically download this library, you can go to package on the bottom right and then install it here, because that enables you to actually import Excel files in RStudio. So first download the data, import it, and if it's imported, you can see it on the top right here. You can see what's included in the data. And to go over some syntaxes first, so you have the command, you just type it, nothing before it, and then there's 2 brackets. And in between those brackets, you have to input which data set you're using. And in this case, it's called Killer App Data. And when you're typing, it also automatically fills it in for you. So if you type Killer App, it connects the dot for you, and you can just press tab and it will fill it in. So if you want to run this code, again, press Control Enter, and then it will appear on the bottom here. So now I just ran the summary of the Killer App Data, and you can see some basic statistics on the categories that they are. A box plot, what the minimum maximum values are, what the mean is. So you can get already a grasp of what kind of data you're dealing with. And if you want to target only one column of the data, so we can see here that there's a column on the price of the data. and you want to see a box plot of that, for example, you can type the box plot, and then you have the brackets. So you first type the data again, then a $sign, and then you can select which of the columns from that data you want to use. And then you can press Control Enter again, and the graphs, they show up here on the bottom right in the plots screen. So again, for now, see if you can get the data imported and see if you can tell from these numbers what kind of data it is. Is it ordinal, nominal, interval, or ratio data? And see if you can get a normality from it. See if it's normally distributed, and if not, can you make it normally distributed? And those transformations I just mentioned, they don't necessarily always work. They're often used and they often work, but not in every case. So don't be disappointed if it doesn't. So if there are any other questions, I guess we can get started with this part.
Yes, so let's talk about qualitative data analysis. I think what Marco said in the introduction still applies. It's a very different way of doing analysis. It pertains more, I mean, it's a bit self-explanatory. It pertains qualitative data. So anything that you can transcribe from interviews or collect in terms of, I don't know, cultural probes, workshop materials, even websites. So all those things that are more on the qualitative side of data. But I will leave the explanation of how to do qualitative data analysis to an expert. So we're gonna watch together. I'm gonna broadcast this video, which for me is super simple. It really explains, the basics of thematic analysis, which is a kind of qualitative analysis, but it can be applied to different data sets, unstructured data sets. So let me broadcast that for you. It's very short, it's just 6 minutes, and it's super clear. And the interactive part of this workshop is really going to be based on these steps that this professor from Sweden tells us about.
Qualitative analysis of interview data, a basic step-by-step guide. Part 1, a description of each step. Step 1, reading the transcripts. Quickly browse through all the transcripts as a whole. Then make notes about your first impressions. Reread the transcripts again, one by one, very carefully, line by line. Step 2, start labeling relevant pieces, such as words, phrases, sentences, or sections in the transcripts. And these labels can be about actions, it could be about activities, or whatever you think is relevant. And this process is called coding, or sometimes it's referred to as indexing. Here's an example of an interview transcript that has been coded. So how do I know what to code, you might wonder. Well, you might decide that something is relevant to code because it is repeated in several places, or perhaps it's something that surprises you, or it might be that the interview, him or herself, explicitly states that this is important, or you have read about something similar in previous published reports, for example in scientific articles, or it reminds you of a theory or a concept, or for some other reason that you think is relevant. You can use preconceived theories and concepts, or you can be more open-minded. You can aim for a description of things that are superficial, or you can code and aim for a conceptualization of underlying patterns. It's up to you. It's your study and your choice of methodology. You are the interpreter, and these phenomena are highlighted because you think they are important. Just make sure that you tell your reader about your methodology and the choices that you make. And you do that under the heading Method. In your coding, try to be unbiased and stay close to the data, i.e. the transcripts. Don't hesitate to code plenty of phenomena. You can have lots of codes, even hundreds. Step 3. Decide which codes are the most important and create categories by bringing several codes together. Go through all the codes created in the previous step. Read them with a pen in your hand. You can create new codes if you want to by combining 2 or more codes. You don't have to use all the codes that you created in the previous step. In fact, many of these initial codes can now be dropped. Keep the codes that you think are important and group them together in the way you want. Create categories, in other words. You can call them themes if you want to. Here's an example. I've grouped these codes together and created a category. Here's a second example, and here's a third one. The categories don't have to be of the same type. They can be about objects, processes, differences, or whatever. Be unbiased and creative and try to be open-minded. Your work now, compared to the previous steps, is on a more general, abstract level. You are conceptualizing your data. Step 4. Label categories and decide which are the most relevant and keep those, and also decide how they are connected to each other. Label the categories. Well, in my example, I had 3 different categories. I'm going to call the first one adaptation, and the second one is seeking information, and the third one is problem solving. At this stage, I should also describe the connection between these categories. These categories and the connections are the main results of my study. It's the core of the whole study, at least when it comes to the results. It is new knowledge about the world from the perspective of the participants in my study. Step 5. Here are some options. You could, if you want to, decide if there's a hierarchy among the categories. You could also decide if one category is more important than the others. And you could also draw a figure if you want to. Here's an example that I put together. Step 6. It's time to write up your results. Under the heading Results, describe the categories and how they are connected. Use a neutral voice and don't interpret your results. Under the heading Discussion, write out your interpretations and discuss your results. Interpret the results in light of, for example, results from similar previous studies published in relevant scientific journals in your field, theories or concepts from your field, or other relevant aspects. Part 2. Ending remarks. I have assumed that your task is to make sense of a lot of unstructured data, i.e. that you have qualitative data in the form of interview transcripts. However, remember that most of the things that I have said in this tutorial are basic and also apply to qualitative analysis in general. What does that mean? Well, it means that you can use the steps described in this tutorial to analyze, for example, notes from participatory observations, documents, web pages, or other types of qualitative data. Suggested reading. Alan Bryman's book Social Research Methods, together with Steinar Kvales and Sven Brinkman's book Interviews, are excellent for anyone who wants to dig in deeper and understand how to do qualitative interview research.
I chose this video because I thought it was very clear and very simple how you could use this method to analyze any form of unstructured data sets. And it's very clear, it's very step by step. So I'm just gonna quickly introduce you to the canvas that we created to go from indeed the theory to the practice. And for me, the interesting reflection that I would like everybody to have is what kind of pitfall should we be wary of when we approach unstructured data sets, like for instance our interviews transcripts or our workshop probes, because it's very easy to fall into confirmation biases. Maybe we're proactively looking for something that is not there, or we get stuck into hyper analysis of our data, so then we don't move forward, but then we don't move backward either, and we're kind of like in this frozen zone. Maybe we reach the saturation point that Marco was also discussing in his part of the workshop, when there is nothing else to analyze, and that kind of like freezes us. So that's interesting things that I would like us to reflect upon during the interactive part of this workshop. And from a design perspective, what does it mean? What can we do with our analysis? Are we just generating new knowledge and taking it out into the world as knowledge? Or how can we use this knowledge to steer or inform our design process or our product or our services? If you had a look at the links that we previously share on Canvas announcements, it's very clear how thematic analysis is being used for, in the realm of human-computer interaction, so application, web services, and things like that. So I think it's interesting for us to reflect a little bit upon this. So yeah, I think my presentation was rather short. So I talked about the pitfalls, so the confirmation bias, getting stuck in over-analysis, and so how can this analysis be relevant for our design process, and how we can iterate